Ladies and gentlemen, before I introduce our next speaker, let me share a personal memory. I'm not an engineer, I'm not an electrician, I'm a historian. And I decided about my career many years before YouTube, before internet, and even before microcomputers. And I decided this way because I hated physics. Now I don't hate physics. Thank you very much. But you should thank to our last lecturer today, to Kathy Joseph, the holder of several diplomas in physics, engineering, and scientific education, and to her excellent YouTube channel that I found a few years ago. And that is why I cannot say about me today that I hate physics. I'm starting to like it, thanks to you. And she will speak about the magisterial problem in the history of invention and history of science and also economic history. What was the first? A hen or an egg? What was the first in the period of the first industrial revolution, in the period of James Watt? An experiment or a knowledge? And what was in the last quarter of the 19th century? An egg or a hen? Please, Kate, take the floor.
Wow, converting a physics hater into a physics not hater. I think I should just leave now and forget. I'm so honored. So my talk today, speaking of honored, in my studies, people ask me as an American how I ended up in Poland talking about Michael Dolivo-Dobrowolski, who I just mispronounced. And I said it was because I don't study modern textbooks. I study the original documents. And when I studied the original documents, I realized you cannot tell the story of electricity without the story of Michael Dolivo-Dobrowolski. So I'm so honored to be here and to be part of this. There was a miscarriage of justice, and we're correcting that miscarriage of justice. And I'm so honored to be part of it. Now, as a historian, I believe that you cannot tell anyone's story without the context, without where they came from. And for this story, I would like to tell we've already heard where he came from, his family. But I want to talk about where his ideas came from. What ideas were swirling in the air in the 1800s that inspired him to make his predictions. So I'm not going to talk about him till the very end of the talk. But trust me, they all influenced him. So first, I'm going to talk about a man named Yaroslav to Edison. Now, in 1876, I forgot the date, in 1876, a Russian man went to Paris and to London to demonstrate his arc lamp, his very bright lamp. And you can see the picture of his bright lamps versus the not so bright lamps. And it inspired everyone. Almost the light bulb moment. There is there's money to be made in street lamps. But there was a problem with his arc lamp. And the problem was it only worked with AC current. Now, that doesn't sound like a problem to us right now, but at the time it was a problem because the best generators, called dynamos, were self-excited, which means that they diverted some of the electricity to electrify, and it only worked for DC circuits. So the best generators were DC. So half the companies started with AC, with worse generators, and the other half companies was superior DC dynamos with inferior DC arc lamps. And one of those groups was men named Moses Farmer and William Wallace. Now, the reason I mention these two men in particular is because Thomas Edison was on vacation with a friend, and the friend said, "Come see my friend, William Wallace. He has a really cool toy." So they went and saw the really cool toy, and Edison was just like, "That's it. I can make it work, and I can make it work with incandescent light bulbs." Now, you might think, why did he think it would work with incandescent light bulbs, as incandescent light bulbs hadn't been invented yet? But you're wrong. Light bulbs are the oldest invention that you've ever heard of. The first light bulb was invented in Isaac Newton's time. And the first incandescent light bulb was invented in 1806. The problem wasn't an incandescent light bulb. The problem was an incandescent light bulb that will last more than 10 seconds. Because otherwise, but Edison thought he could use thermocouples. So he told all the newspapers, "I'm going to do this." He made all these promises. He got all this money. And then he realized after about 2 weeks that the thermocouples took too long and it didn't work. But by that time, he was too deep and he had to make the light bulbs work, which took him, it took him till 1879 to make a good generator, DC generator, which he called Long-Legged Mary Ann, which I just think is funny. She has long legs, but she doesn't seem to have much else going on. And it took till 1882, 4 years after he promised that he would light up New York in 2 weeks, for him to make his first power station. And Long-Legged Mary Ann is lying down, if you see, by this time. And he was very excited. And that's when, just then, came news that AC might be better. Part 2, Gaillard to Westinghouse. So Lucien Gaillard had been looking at something called a spark gap generator, which, if you look at it, is a step-up transformer. But it was used to make sparks. And he realized that some of the wires got hot and some of the wires did not. But it would only work for AC. So in 1882, just after the power plant was put in New York, Gaillard filed, and his financier, Gibbs, filed for a patent. Transfer the electricity at very high voltage, so very low loss, and then use these coils to step it down, which he called secondary generators. And he showed it in 1884 in Turin, Italy, and it was considered a huge success. We've got it for AC. Actually, Edison hired someone to look into it, and the person looked into it and said, "Go for AC." And Edison said, "I've put too much work into DC. I'm not doing it." But another person named George Westinghouse Jr. read about it in a magazine, immediately hired a Gaillard employee, and then immediately realized that the Gaillard transformer was no good, remade it himself to a better transformer, and started his own company, which was his 5th company. Every time he had an idea, he started a new company. And this was called the Westinghouse Electric Company. It was all AC, all incandescent light bulbs, but no motors. In fact, not only did they have no motors, they had no meters. They had no way to figure out how much to charge people. They literally had to charge people by the day because they had no way of, which encouraged people to leave it on all day because they had no meter. And this is his transformer. Sorry, a little out of sight. Unfortunately for Westinghouse, Edison was very upset about this and started what's called the War of the Currents, which Westinghouse was quite surprised about. Actually, there's notes like, "Dear Edison, remember when I visited you before? We seemed like friends. Why are we fighting?" And Edison's like, no, you suck. This is terrible. Get rid of AC. So they're fighting with each other and publishing things. Okay, part 3, Ferraris to Tesla. Galileo Ferraris is a man of my own heart, as he is a physicist, and he was an Italian physicist who was in charge of judging the electrical demonstrations at the Turin, and he judged Gallard's exhibition of the AC transformer and was so well respected that when he said that it was good, everyone thought it was good. And he started thinking about what a shame it was that there was AC transformer, but no AC motor. And there's he writing about it, sorry. And Ferraris, as a physicist, was thinking about how light, if you take linearly polarized light, vertical light and horizontal light, and you combine them, you get diagonal light. But if you combine them at a 90-degree phase difference, you get circularly polarized light. And that's what inspired Ferraris to say, if I have two AC systems 90 degrees apart, I can get a motor that spins in a circle, which is exactly what he did in 1885. However, he didn't think it would do much work, so he never patented it. In April of 1888, Westinghouse paid him $1,000 for this. And at the same time, one of his employees made a meter so he could finally charge people for when they had the lights on. And just like a month after that, Westinghouse heard that there was another AC two-phase motor from a guy named Nikola Tesla. And this one was patented and looked more industry ready. So he paid him $70,000, a lot of money for 1888. This did two things. One of the biggest things it did was that every engineer in the world went $70,000. It was like the musical, you know, $70,000, $70,000, $70,000. Everyone said, I'm going to try my hand at an AC motor. Including our friend Dolivo Dobrovolsky, not only because they wanted the money for themselves, but they knew that if they built something and got a patent, they could encourage industry to build something with it, as Westinghouse had already encouraged it. Oh, by the way, if you're wondering about the differences between Galileo's two-phase and Tesla's two-phase, according to Tesla, there wasn't any. It was exactly the same down to every last detail, I think he put it. But unfortunately for Tesla and Westinghouse, they couldn't get the two-phase motor to work for industry. Meanwhile, Dolivo Dobrovolsky decided to make a three-phase. And his three-phase did work. Part 4, Dolyvo-Dobrovolsky. Okay, so from Yablokov, he knew electric lights can be commercial. From Edison, he learned electric lights and DC motors are commercial. From Goddard, transformers allow AC to go great distances. From Westinghouse, AC electric lights are commercial. From Ferraris, two-phase AC motor possible. From Tesla, two-phase AC motor profitable. All of this combined for him to work on the three-phase motor. And he also did the squirrel cage, so noted because I guess it looked like you could put a squirrel in there. I don't know, that's the first instance they called it a squirrel cage. And that's where it came from, not from Dolyvo-Dobrovolsky. He did not call it that. An American put it in a book. He says, it's a so-called squirrel cage. And we've been stuck with it ever since. But he did something else with it. He not only he realized there's something special about three phases. Let's see if I have the picture. If you have three phases, no matter where you are, if you combine them all, you get a neutral. So a three-phase generator should have 6 wires, but he could take 3 of those wires and ground them and only transmit 3 live wires, which is exactly what he did. So he had only 3 wires, and that's his drawing. That's Dolyvo-Dobrovolsky's drawing of the 3 phases and how they always add up to 0 if you add all 3 together. And he made 2 kinds of transformers, the delta and the Y, or different names, which we still use to this day. And if you look at the transfer, he transferred the energy from an actual waterfall, transformed it, and then powered a waterfall, which I think is kind of poetic. And must have impressed the heck out of the people there. I can't imagine. Where a single light bulb impressed them, an artificial waterfall must have blown them away. And this is a drawing of his, a simplified drawing. And you can see in the middle, he only had 3 live wires, which means he only had to use half the amount of wires, which vastly reduced the cost, which is why we use 3-phase to this day. And that's why he was so influential on our world. Thank you.
So, ladies and gentlemen, it was the last speech during this session. So, thank you very much, all speakers. It was really inspiring us. So, we know everything about the history. We know how it was developed, the AC machines since development till now. So, we know how we improve the efficiency, how we make lighter AC machines. And now we know how looks the history of development of the AC current. So thank you very much. And there's a coffee break now. So there is we fully deserved to have the coffee break.